Next section, 5.2, applying properties of similar triangles. A couple theorems that we're going to learn today. The first one's called the triangle proportionality theorem. It says this: if a line is parallel to the side of a triangle and intersects the other two sides, it divides those sides proportionally. So let's take a look. If a line is parallel, that's what those arrows mean, to a side of the triangle, and it intersects the other two sides, it divides those sides proportionally. There's our proportion. AE over EB is the same ratio as AF over FC. Let's take a look at a problem with that. Given that the two lines are parallel, XY and BC, as soon as you see that, you know that the two other sides are divided proportionally. Find CY. So I know that AX over XB must be the same ratio as AY over YC. I'm going to write it as CY. Okay, cross multiplying, 10 times CY is just 10 CY. 14 times 8 is 112. Dividing both sides by 10, we get CY is 11.2. Next one, given that DE and BC are parallel, we know the two other sides are automatically divided proportionally now. I know CA is 10, that big piece there. CE is 2, and DA is 6. Find the measure of BD. All right, so the first thing we probably should do is find the measure of EA. So 10 minus 2, this side would be 8. So now I can set up a proportion. AE over EC is the same as AD over DB. 8 times DB is equal to 6 times 2, which is 12. Divide both sides by 8. We get our answer of 1.5. So DB or BD is 1.5. The next theorem is called the two-transversal proportionality theorem. If three or more parallel lines intersect two transversals, they divide the transversals proportionally. So here are our parallel lines. You can see there are three or more of them, but there's three of them here. And here are our two transversals. It divides them proportionally. So let's take a look at a couple of proportions and fill in the blank. AB is to DE as BC is to EF or FE. AB is to AC as DE is to DF or FD. AC is to CB as what is to EF. That would be this big side here, DF or FD. And finally, AC is to DF as BC is to what? That would be this one over here, EF. Okay, so that's just how we would write some proportions using the two transversal proportionality theorem. So let's take a look at one of those. Solve for x and y. We see the four parallel lines cutting those transversals. It means they cut them proportionally. So our proportion, our ratio here is going to be 8 to 6. So 8 is to 6 as x plus 5 is to x. Cross multiply, 8x equals, distribute 6x plus 30. Subtract 2x. Divide by 2, we get x equals 15. All right, let's put that back into our equations, our expressions over here. I know this side is 15 plus 5, 20. I know this piece right here is 15. I know this piece right here is 15. All right, to find y, we're going to use the same ratio, 8 to 6. Now we're going to use these two. So 2y plus 6 is with 15. So 8 times 15 is 120. Distribute the 6, we get 12y plus 36. Subtract 36 from both sides, we get 84 equals 12y. And divide both sides by 12, we get y equals 7. The last theorem is the triangle angle bisector theorem. So looking at the picture, we can tell right away, because of these arc marks here, that CD is an angle bisector. Going back to chapter 1, that tells us the two angles are congruent. Angle ACD and angle BCD are congruent. But now this new theorem, let's read it here. An angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. So it divides the opposite side, which is this side, into two lengths. AD is to DB, whose lengths are proportional to the lengths of the other two sides. Okay, AC is closer to AD, so AC goes on top. CB is closer to BD, so that goes on the bottom. So there's our proportion. So let's take a look at one of those problems. Find PS and SR. So we see the angle bisector right here. So that immediately tells me that PS is to SR as PQ is to QR. So this piece is to this piece as this side is to this side. So that means x plus 2 is to x minus 5 as 40 is to 32. Okay? Cross multiply, we get 32x plus 64 equals 40x minus 200. Subtract 32 from both sides. Add 200 to both sides. And divide by 8. We get 33. The question says to find PS and SR, put 33 back in, we get 35 and 28. All right, go ahead and pause the video. Come back when you're done with the last slide and check your answers. All right, here's the answers to the last three problems, 5, A, B, and C. Pause the video there to check your answers. When you're done, that'll be the end of section 5.2.